So today's daily question 165. Compare virgin numbers. This is medium, not very hard. Given two virgin numbers, virgin 1 and virgin 2, compare them. Virgin numbers consist of one or more revisions joined by a dot. Each revision consists of digits and may contain leading zeros. Every revision contains at least one character. Every revision contains at least one character, maybe zero. Revisions are zero indexed from left to right. Revisions are this is a revision, this is a revision, and this the whole part is a version. The leftmost revision being revision 0, the next revision being revision 1, and so on. For example, 2.5.33 and 0.1 are valid version numbers. They are all valid. To compare version numbers, compare their revisions in left to right order. If this is left to right order, this means left is have a high priority. If some left part is less, then the other part is not compared. For example, 0.2 will be less than 1.1, minus 1. Revisions are compared using the integer value ignoring any leading zeros. This means that revision 1 and 001 are considered equal. 1 and 001 are considered equal. This is equal. If a virgin number does not specify a revision at an index, then treat the revision as 0. For example, version 1.0 is less than version 1.1 because their revision zeros are the same, but their revision ones are 0 and 1 respectively, and 0 is then less than 1. Return the following: if revision 1 less than revision 2, return minus 1. Just as the string compare strcmp. Revision 1 greater than revision 2, then return 1. Otherwise, return 0. Example 1. They are equal. Ignoring leading zeros, both 01 and 001 represent the same integer 1. Example 2. Still equal. If a revision number does not specify a revision at an index, then treat the revision as 0. 0, 1, 2. The revision 2 is not specified, so it is 0, and this is 0, so they are equal. Example 3. Input 0.1, 1.1, so this is less, minus 1. Constraints. Revision length not very large and only contain digits and dot. Revision 1 and version 2 are valid version numbers. All the given revisions in version 1 and version 2 can be stored in a 32-bit integer, but they may overflow let's write it. Let's draw it. They are equal. Example 2. Still equal. Example 3. -1 less, because the relation 0 is less, so just return no matter what. We can change this to 0.2. Yeah, still less, still -1. This is somewhat easy. We can just find this dot. When we find this dot, then the left part is counter relation, and compare the two relations. If they are not equal, then we just return 1 or -1. Yeah. If it is greater, then we return 1. If it is less, then we return -1. And then we get the last part and get the revision. Not so hard, just about it. Okay. Use I to add to the index of the first relation and the J to index the second relation. And if some I or J, some part is not trimmed, then we first of all, we need to reset. Dot. Then we just add a counter digit, and J is the same. Great, then we return 1. Yes, we return -1. Then we need to move the I and J from counter dot to the right part, and then check again every revision. And at the end, set it to 0. The constraints, they are at least 1 and not a dot. So, by the way, it's a good habit to initiate no matter whenever you use it. And when and we come to this part. It is equal. Complexity O M N n plus n O1. We don't need extra space to store anything, just 1, 2, 3, 4 int and 2 int 64. This is somewhat not so hard, easy to understand and easy to write. Or we can write a local function or lambda to get the relation and then compare it relation. The acceptance, why? Well, the acceptance rate is so low. This is not so hard. Maybe it's because this in the 64 it will overflow when we plus 10. A relation can be held, but when we plus 10 it will overflow. Okay, so not too hard. So now let that question about this question. Okay, thanks very much. This is today's question.